Good afternoon, everybody. Has anybody been to one of my previous talk Monday about build fault tolerance microservices? Brilliant. Okay, thank you. And today I'm going to talk about the build 12-factor app, build 12-factor microservice with MicroProfile. For anybody who do not know me, I'm Emily Jiang. I work for IBM. I'm based in the UK, Hursley Lab. So I have been working on MicroProfile for over 2 years. Basically, I'm a very passionate MicroProfiler, we say. Personally, I'm leading quite a few stacks, including MicroProfile config for tolerance, and recently I'm also leading the MicroProfile service mesh specification, and also I'm quite actively involving in some other spec. Basically, my vision is I want to make sure the programming model we define in MicroProfile is relevant to, for doing microservices, and also is we come up with the best standard of the programming model. In this talk, I will talk about MicroProfile in a higher level, basically in the Kubernetes environment. Let's get going. So this is 2 parts. The first part will go through the 12-factor app, and then I will try to demo how to build a microservice using MicroProfile with some live coding demo. So what is a 12-factor app? Has anybody heard of a 12-factor app? Oh, brilliant. So 12-factor app is a kind of methodology. Has anybody know clearly how to do one? No? You are coming to the right place. So today I'm going to show you how to do like a practical 12-factor app using MicroProfile. Is not that complicated once you know about MicroProfile. So I would like to mention 12-factor app is from Heroku. Is kind of vision for designing microservices and to ensure these microservices work well in the cloud. However, for the 12-factor app, actually is trying to define a contract. What kind of things need to be managed by application? What kind of features need to be managed by the infrastructure? So, nowadays, sometimes if you do not, do things carefully, you will end up different level competing with each other, and eventually you create conflicts. And then your application behave really, not very well in some infrastructure. So that's why the 12-factor app come into play, and basically is trying to define contract between the application and the infrastructure. So this is the kind of 12-factor app definition. So it's basically the declare a set of rules for the application to manage, and what kind of things for the infrastructure to manage. And everybody who either the less experienced developer or experienced developer can follow these rules and to operate without any problems. As I said earlier, this is kind of with this vision is kind of the vision is in the cloud. So basically, is once you design this type of application or microservices, you rest assured that it will be perform well in the cloud. And the other thing is trying to push forward between the development and live, there's kind of similar environment. There's not much difference. So in this case, you don't have much surprise. And the other thing is scaling. So basically, it's for microservices, and because it's in the cloud, and it can get used by many other microservices. so it needs to be scaled up and scaled down based on the traffic, so based on the load. So this is the 12-factor app. So when I first started looking at this 12-factor app, this is really, really difficult. I just feel like, oh gosh, these are 12 things. How can I make sure I can do it properly? Actually, in the next few slides, I will go through each one in more details and tell you exactly what it means. So the first one is the code base. So code base basically is trying to say each microservice should have its own GitHub repo. So basically it's like in the demo I'm going to show you later. So it's, there's 2 microservices and then it's kind of deployed to the Kubernetes environment. And each microservice has its own dedicated repository. So in this case, like if you have one team, maybe 4 or 5 people, and work on 2 microservices, and then like a couple people, a manager, I mean, we work on the one GitHub repository, and then there's less merging to do, so people don't trap each other tools. The other good advantage to have a dedicated code base for per specified microservices is that it can go through its own maintenance. So basically, some microservice needs to change all the time, and other microservice doesn't need to be updated that frequently. In this case, like you can easily maintain the life cycles of the microservices. Do you I mean, how many of you are doing microservices? Good. Do you use these best practices? Brilliant. Who using it? Oh, excellent. You are doing the right thing. So the second one is dependencies. So dependencies basically is trying to say is you do not package your dependencies, your third-party libraries inside your application. You should always use Maven or Gradle to declare your dependency. So basically, it's, you just specify the group ID and an artifact ID and a version, the automatically pulling from the Maven Central. In this case, like you can always upgrade your dependencies, just trying to increase the version and etc. And then it's very easily to be managed. Once you package your own library, and you will end up into the situation like you carry that burden with you all the time. You could end up with the like older version, the libraries, and never being able to move up. So how many of you use the Maven? Good. Oh, Gradle? Okay. Yeah, I think according to the survey, Maven is still more popular than Gradle. Yeah. So anyway, the 2 things are comparable. So the third thing is config. So basically, this config is trying to say the externalize the configuration from the application. So in this case, like the config is changing all the time. Basically, in this case, if you let it reside outside this application, every time when you change, you do not need to repackage your application. So you just change like the key value and outside the application, and then your application can continue running, but it will react differently if you change the configuration. So the best practice is if you deploy this microservices in Kubernetes, and the configuration should be specified in the Kubernetes environment. It shouldn't be like hard-coded in your application, and then every time when you change the value, you have to repackage your application. So the best practices is you can supply the initial version in the application. However, Kubernetes environment can overwrite that config, and then you can use MicroProfile config to inject the proper value into your application. The fourth one is the backing services. Basically, is in the service mesh or in the cloud, every microservices, is not standalone. So microservice A could call into microservice B and also interact with some other microservices. And in this case, like all its kind of backend services should be treated as attached resources. So you can easily switch. From, for example, here you can switch providers. For example, now you can use Twitter, or maybe in the future you can use LinkedIn, for example. So it's all these kind of backend resources should be configurable. So you can freely to be able to switch the backend resources via the configuration. You can switch out and switch in. Swap out or swap in. The fifth one is build, release, and run. So basically, it's, so microservices, there's a kind of 3 stages. So in the build, basically, is in the development, and then you do for example, if you are using Maven, you do a Maven clean install to do the build, and then you can release it, and then you get it running in a Kubernetes. And first, you build a Docker image, you do a Docker run, and Docker build, Docker run, and it can run in your Docker image. And in the Kubernetes, you just like apply the YAML file. It will create the deployments, and automatically we start the service. So this is some like in the microservices world, because each microservices could change, very frequently. So you need to like build, release, run. Probably you each day you might need to push up different version releases, and you do need some tooling like a CI/CD pipeline. So you change the code, automatically kick off the build, and then push it to the Docker Hub, and automatically pulling by using pulling to the Kubernetes environment. And this sixth one is the processes. So this is really, really important. So in this 12-factor app, it says these processes should be like stateless. So basically, it's, why it should be stateless? Why shouldn't it contain the state? It's because this is microservices could be destroyed or could be restarted by Kubernetes at any moment. If the microservice, for instance, not responding, Kubernetes will kill it and start up a new instance. If it's like have its own states, and then it's like when Kubernetes killed the pod, or killed the service, you lost everything. So that's why it needs to be stateless. So to build the stateless microservices and or processes, the one's available technology is to use JAX-RS. So RESTful API. So the seventh is port binding. So for this port binding, like if you think about microservice A call into microservice B, like when you locally deploy the microservice B, and you can manually bind to like, for example, 9080, and the microservice A knows, oh, okay, your microservice B is on the port 9080. However, when you deploy it into the Minikube to Kubernetes manages the port. And you cannot, many Kubernetes assign you the port. Basically, you specify in the YAML file, you said, okay, this is port, you will be banned. And also is in Kubernetes, by default, your port is not available to the externally. So your port is visible inside that cluster. That port is only exposed when you tell it to be exposed. So in this case, you cannot force to hard code your port and then have that port forever, because because it's in Kubernetes and a YAML file, I could specify a completely different value. If you hard code the port, your service A always trying to invoke service B by using port 80, and once it's DevOps team change the value, change the port value of the service B, and your service A will stop working. The eighth one, this one is the concurrency. This concurrency is like when you look at the concurrency, you will think, oh, okay, this is about multi-threading. But this is kind of infrastructure concurrency. So basically, it's trying to say is like Kubernetes will say, actually, this is the kind of service is under heavy load. I want to scale up. So in this case, like one service can be scaled up to 2 instances or 3 instances. If it's very quiet, can scale down to like 1 instance, for example. This factor is disposability. So this disposability is trying to say actually you always should treat your microservice as a cattle, not as pet, and basically, it's trying to say you shouldn't put any special feeding towards one particular instance or microservice. All the same microservices, like if you are different instance or microservices or the same for the same operation, this should be exactly same. So it's cattle, it's not a pet. You know, if you have a pet, you give it the pet name, you observe its behavior. They are unique. They are unreplaceable. So if you have a pet, and is unique. Basically, is indisposable, displaceable. For cattle, if one cattle is not doing well, and you can easily replace with another cattle. So this is the other thing is you always should bear in mind this is your microservice should be a fast startup and a gracefully shut down. That's because Kubernetes could kill this microservice at any point in time. If it takes ages to start up, like you cannot serve the response, you cannot serve the request. So it's not going well. And also you should always bear in mind that your microservice is kind of bulletproof, is resilient. So it's basically it can survive under all kinds of circumstances. This is one thing. The other thing is like it can start up, restart it very fast, and also can be shut down very gracefully. Basically, it's elegant. Just see that. So you can use even use a health check to tell Kubernetes when this service is not healthy, and Kubernetes can destroy it. Or you can use the MicroProfile programming model fault tolerance to say actually this is to make it very fault tolerant. So the next one is dev productarity. So basically, it's trying to say is keep your development and also the production as similar as possible. I think it's 10 years ago, we have a different even team infrastructure. It's a team. Okay, you have a development team. And then you have a testing team. You even have a different manager, like development manager and testing manager. Basically, different people doing different work. Basically, development just writing the code, and the tester the development. You often a tester reads a bug and say, "Oh, it's not working," and developer say, "No, it works on my machine. Why is it not working?" So this is trying to say, make sure it's even the same people to do the testing, to do the development, and even to maintain the production. So basically make this kind of people and the process and the environment as simple, as the same close as possible. And also is the other the best practices. Anybody heard of Helm charts? Very good. So the other best practice, when you write a YAML file, deployment YAML file, that's very error prone. And there's a Helm chart. So basically, you have a template. It's very easy to maintain, and is less error prone. So very easy. You can deploy the microservices like using the Helm. The next one is logs. So it's this best practice is you treat logs as streams, as event streams. Why is kind of saying you should treat logs as an event stream? This is because in the distributed system, and if you write like logs in the file, you have to correlate it. You don't know where the file is written to, and etc. So if you stream out, and at real time, and you can use Elasticsearch, Kibana, and etc. to kind of to look at the logs and etc. Yeah, okay. So the next one is admin processes. So admin processes this is kind of important. However, you shouldn't this admin process, like a database migration, and like some other one-off tasks. So this is 12-factor up methodology is saying actually for these one-off processes, you should not put together with your application business logic. It should be one-off. It should be executed using kubectl exec. So it's doing this job. It's like database migration, etc. You can do the. You shouldn't put the database migration inside together with your business logic. You should have a you should have a dedicated job to do so. Okay, this is a 12-factor app, and so the first one is the code base, which is GitHub repo, one per microservice. The other one is dependencies. You use POM Maven or Gradle to specify the dependencies. The third one, the config, you use MicroProfile config to specify the configuration. The fourth one is backing services, so you can use MicroProfile config to configure the backing services. And the fifth one is process. Basically, is build, release, and run. Is kind of 3 different stages. And also the processes, you can use JAX-RS to create this the RESTful processes using these RESTful APIs. And port binding, you can use MicroProfile config to do so. Concurrency, you can use Kubernetes scale, basically a replica. So how many versions per service you want. And disposition, you can use fault tolerance, and you can use a health check, and to make sure your microservice can tell Kubernetes whether they're healthy or not, and to make sure your microservice is resilient. And the 10th one, the dev productarity. Again, this is kind of best practice. This is a process, and the logs is also process. Admin processes basically is another process. Basically is one-off processes should be just created as a standalone job. I mentioned quite a lot about MicroProfile already, and all the different technologies inside the MicroProfile. I said config, I said fault tolerance, I said the health check. So MicroProfile, anybody know MicroProfile? Yeah, great. So yeah, so for the ones who doesn't know MicroProfile, MicroProfile is an open source community, is completely open source and very friendly community as well. So IBM is one of the biggest supporter in MicroProfile. It has IBM, Red Hat, Piara, and learn the Java community, and Oracle, and also Microsoft. They all support MicroProfile. And MicroProfile is a kind of established programming model for developing microservices. You can see on the right-hand side, there's a lot of application server for you to choose from. Like IBM has Open Liberty. Open Liberty, anybody know Open Liberty? Wow, great. For the one who doesn't know Open Liberty is completely open source. The Liberty, open source Liberty, who has the Java EE8 and the MicroProfile implementation. And also, if you want, it's completely suitable for the production user as well. It has a support model if you want to support a service. And also WebSphere Liberty, and also the Red Hat has recently rebranded Songtail, and TomEE. Anybody know TomEE? Yeah, TomEE also supports MicroProfile 1.3, just recently started. And Helidon, so Oracle recently released Helidon. Helidon also started supporting MicroProfile. Currently, it's support MicroProfile 1.1, which has a config. So for the whole package of MicroProfile specification, this is 8 new ones: config, fault tolerance, and health check, and metrics, JWT, open tracing, open API, and REST client. If you want to participate in this community, you are welcome to check out MicroProfile or click on the join discussions. You can share your ideas and get involved in any specifications if you want. So I quickly go through the MicroProfile config. So config, this is kind of externalize your configuration from your microservices, and it provides API for you to inject the configure properties. So in the example here on the right-hand side, so you can see that this one is kind of SPI. You can directly get hold of all the configuration. If you wanted to know the myprop value, you can use the get value. And this one is the kind of CDI version. So this is much easier. You just do an inject and can directly inject the my.string.property into the myprop. The fault tolerance is very, very nice and sleek. Basically, it's just have this. Just has these annotations. So you can see. So this is retry. So basically, it's kind of fix all the like network glitches is for retry, and also circuit breaker. This is prevent from the repeatable errors or timeouts, and also it is a bulkhead to like isolate the microservices with limited resources. Basically, this prevent from one microservice using up all the underlying resources. And timeout is like if your one backend doesn't respond, you can specify if within this like a few minutes, if a few seconds or a few milliseconds, if it doesn't respond, I want to return back with error, timeout error. So you can deal with it. You can either fall back to do some other things. And this is very powerful, the fallback. So, you know, all these kind of things is trying to recover, trying to try the best, trying to get a successful a result. However, is under some circumstances, and you might still get a failure. And this is a backup, so you should always have a contingency plan. So this is fallback. So the next one is the health check. So health check is the provider way for machine-to-machine communication. So basically, for your microservice, tell the underlying Kubernetes is saying, okay, I'm not healthy. So the implementation is directly, you can annotate, it automatically come up with the endpoint. You can annotate with the add health, and then you can implement a health check API. And it will automatically display and the health check response. So Kubernetes has a way to poke this health check endpoint and frequently to see whether you're healthy or not. So this one is the REST client. Anybody know JAX-RS? JAX-RS? Very good. So JAX-RS, for creating a client is quite clunky, right? You have to specify URL and do it. And if you make a mistake, okay, it's not working, but you do not know. You have to figure it out. It's not very nice. And the REST client, MicroProfile REST client, creates the type-safe way to directly to bind into your client. So basically, it has, in this example here, you can register a client, and then later on you can inject the client. So all you need to do is you just specify the API of this client. And then you need to bind this client. You just need to specify the backend service URL as a property using MicroProfile config. And it will automatically find the backend service. Okay, I will use a few minutes and try to do a quick demo. So in this demo, I will try to create a microservice and service A trying to talk to service B and demonstrate to use config for tolerance and health check, and the REST client and using Open Liberty. It's just before when I plug into this project, my machine crashed. So let's see how it's going. Okay, see everything crashed. So just need to start up my service B. So this is I'm using Open Liberty. So I have the app written to deploy to Open Liberty. I can show you my app here. So it's, you can see okay? Yeah? So this app has a health check, so you can see the health, So you can see this health, you can tell the health check response and put this, can do a build, and this is kind of data, is a payload, and this is, you can say, okay, I'm up, and this is not healthy, I'm down, etc. So this is service B, and then service B is JAX-RS. You can just say service application extends application, and you can see service B, hello, and in here is there's sometimes it doesn't work, I did on purpose. Now it's ready to start. Let me see it. It's bound to service B9080. Yeah, you can see it's trying to do things quite slow. And later on it will fail. This one not fail, and this one it failed, right? So this is just trying to demonstrate here. Sometimes it doesn't work, and then anyway, it doesn't work. However, I do want to use it, and okay, I can see what kind of service is offer. So I can see Open API. So I know it has hello and return a string. Yeah, so that's enough for me now. So now I want to create a microservice in this 12-factor app A. So Java resources. So I have nothing. I haven't got any class whatsoever as yet. So I want to create a restful microservice. I want to call the service B. So now I need to new a class service A up. Oh, this is really odd. I cannot even see this. Anyway. This project is not very well, not very good. Oh gosh. So I do an application path and then give it demo. Okay, manage to create one, and then I create a endpoint. So I want this is to be a resources, just as resources. I bind to the /A. And also I want to create an endpoint. I would say core service. Okay, I want to say it's a get operation. Okay. Oh, very it's called this is called a string. I want a string version. Can you see it? It's a 10 no, string. Simple. Can't remember the. Okay, quickly. What's it called? Okay, that's fine. I don't need to get that. Now I need to call service A. Call service B. And return calling. Okay, now I need this one to call service service B. How do I do it? So I only need to do service B endpoint, service B client. So here I can just say register REST client. So you know earlier I showed service B has a hello backend source. Exception. So this is service B. So now I can easily call service B. Basically, I can just say @inject @REST client. I say service B client like that. Now in here, I can say client dot hello. That, yeah. Okay, so I demonstrate REST client and this one. However, I want to make sure this is kind of has a fault tolerance. Basically, I can do, if something not working, I can do retries. I can say, okay, maximum retries 3 times. Oh, no. Back. I can easily say fallback. Basically, if something not working, I can fall back. I can specify the method name. Now I just need to create a fallback. I can see fallback. So basically, if something not working, eventually you won't get an error. You can just directly do a fallback. We'll automatically call this method. Okay, so this is the fault tolerance and also REST client. And the other one, and you can create the health endpoint. So this is a very easy. You can do a bin. So with that, so this is a health check API. It automatically gather this status for you. Extends health check. Oh no. Oh no. Okay. Once I get the health check. It's very, it's not a let me copy this one, health check. Oh, you are right. You are so right. Why is it not working? I need your help, guys. Okay, I was, so basically you just directly call that. And then you do a Maven clean install, and it will build it up. So I know my time is nearly over. So I have all the code in the GitHub, and also is, let me quickly show you. Show the slides here. So all the code is in the GitHub. You can check it out and build it yourself. So I highly recommend it. You go to openliberty.io and to find out MicroProfile guides. And also we have an IBM booth downstairs. Also there's a quick lab, so you can try out all the quick labs to be able to get the t-shirts. If you have any questions, I will be in the downstairs tomorrow or later today. And yeah, thank you.